Hi, welcome to Imperium Learning. I forgot to upload I forgot to mention something at the end of my last video um, in relation to how to estimate an ARMA model, which is to do with residual testing. Now, whenever you estimate a model, you have to do some residual tests, even if it's just one or two, although really you should do more, but at the least do a couple just to make sure that your ARMA model is appropriately specified. Now, I'm going to be doing two tests in this video. It's on my ARMA 4.2 specification, um, and I'm just going to show you right now how to do it on Eviews. So bear in mind that the first test that I'm going to be doing is the lung box test. Right, that's how you spell it right there, lung box test. And bear in mind that when you do this, you have to specify a number of lags that's at least one above your terms in brackets added together. So in my case, my ARMA model is a 4-2. So P equals 4, Q equals 2. So in this case, the bare minimum number of lags that I can choose for my lung box test is 7. I can do more, but that's the bare minimum that I have to do, 7. And just here I've written down the null hypothesis and the alternative in some plain English, just so that you can understand it. Null hypothesis is that the data are not serially correlated. So what we'll be looking out for is a p-value of less than 0.05. If we do have a p-value of less than 0.05, that means that our data is serially correlated, and that's going to cause some trouble. But anyway, let's just go on to back onto Eviews now, just to do some residual testing. So all you have to do the lung box test, you click on View, you click on Residual Diagnostics, and then we're going to click on Correlogram. And as you can see, it gives you a number of lags that you can choose. Let's just choose those 6. It's certainly a lot more than 7. Now bear in mind, for the first 6 lags, look, 1, 2, 3, 4, 5, 6. Notice that you haven't got any p-values at all. Absolutely none. And that just, again, like I said, when you were looking at that PowerPoint slide, you have to do a minimum of 7. So that's where the p-values start, at the 7th, for our ARMA 4.2 specification. Now as you can see, our p-values are well above 0.05. It literally starts at about 0.5, so we're well above. And if we just scroll all the way down, we can see quite clearly that none of them have a p-value of below 0.05. So we can conclude straight away our ARMA specification is quite good, just because it doesn't suffer from any kind of autocorrelation. Now, the second kind of test that I wanted to introduce you to is the Arch Lagrange multiplier test. Now what does ARCH stand for? Well, it stands for autoregressive conditional heteroscedasticity. It's quite a mouthful, but I don't think you even really need to memorize what it stands for. You just need to know what it is. And you just need to know that this is particularly important to apply when you're dealing with any kind of financial time series data. So in my case, this particular data set that I have is based on an index fund, and so obviously this is my variable there called returns. That's the returns of the index fund, and so obviously that would be classed as financial time series data. So as a result, we really need to apply this. Now bear in mind, why do we apply this test? Well, we apply it normally because it's normally a prelude to estimating certain kinds of arch or gauge models, and we'll be estimating a whole load of arch and gauge models later on. Now, just moving on to the next slide, I've just sort of summarized how to do the test, what the null hypothesis is, and what the alternative hypothesis is. So as you can see, all we're doing is regressing the squared residuals of our model on a constant and p lags of the residuals, and then we obviously have to find out the optimal lag length for our test. And again, I'm going to be showing you how to do this on Eviews and Excel. It's a bit time consuming, but nowhere near as time consuming as finding the ARMA model. So again, all we're looking out for is a p-value of below 0.05. If it's below 0.05, that means the residuals of our model suffers from autoregressive conditional heteroscedasticity, right? And that's going to be problematic. If, however, it's above 0.05, that's a good thing. So just bear in mind, you want to see a p-value that's above 0.05. So let's just move on to Eviews. So how are we going to conduct the test? We're just going to click on View, we're going to click on Residual Diagnostics, and then we're going to click on Heteroscedasticity Tests. Just ignore that. And you're going to click on Arch, and as you can see here, let's just try one. And as you can see here, and again I'm going to choose the Schwartz information criterion, we've got a value, minus 12.07818. So all we need to do, now bear in mind I've already done this on my Excel file already. So as you can see there, what was the minimized one? Hang on. Yeah, so the minimized value right here is minus 12.07818. That means just with one lag. And basically you can just find the optimal lag length just using trial and error, you know. Just type in 1, 2. I did it up to 8 lags just to check that I'd minimized it, and clearly you can see it's becoming more positive the more lags that you add in. So just using trial and error, all you have to do is you can do that on Eviews. So if we wanted, we could go back to Eviews and we could do the same thing, go back to Residual Diagnostics, go onto the Heteroscedasticity Test, click on Arch, and we could click 2. And as you can see, our value there, minus 12.07537, which is right there. So basically all you need to do is find that if your values are negative, find the value that's the most negative in order to minimize your information criterion. Now just going back and estimating it with one lag, you can see straight away, and this is the row, by the way, that you need to look at, the observations times by the, that's your test statistic for the arch test right there, 111.7. Ignore that, the F statistic. It's not the actual test, it's the second row, obs multiplied by r squared, your F statistic, and your p-value. Right here, the p-value is 0.000. That means it's way below 0.05, and because of that, that means we have arch effects present in our residuals, and that means you can start estimating arch and gauge models in order to try and remove the arch effects from your residuals. Okay, so I think I'm going to wrap it up there. Hopefully I've shown you what to do. Okay, bye now.